Voice of Industry.
Voice of Industries.
Maxime, welcome to Voice of Industry. I'm glad to have you today to discuss about managing climate risk in the industry. First, could you present yourself and also the activity of your company, Rong Yi?
First, Mathieu, thanks for having me. I'm really glad to be here today. I'm an engineer by training, and I started working in 1997 in the petrochemical industry. And I had jobs for 23 years in the same company, ExxonMobil, in which I had about half of my time spent managing plants, factories in different roles, in production, technical, financial management, as much as in supply chain. And half of the rest of this career managing businesses, mostly globally, gravitating towards marketing, global marketing, especially for distribution of polymers into a wide array of different applications. And in 2020, I founded Rong Yi Solutions. I'm the co-founder of Rong Yi Solutions. And what we are doing is it's actually a boutique consulting that is addressing climate specifically. And we're a purpose-driven company. And our mission, stated in our charter, is that we want to contribute to adapt the world to climate change and to contribute towards carbon neutral world by 2050. So that's really what we are doing there.
We are here to talk about managing climate risk. Could you define a little bit more what we are talking about? And also, if you can give us some example of common climate risk that industrial may have to manage.
Certainly. So, broadly speaking, there are two types of risks. The physical risks that a company, that any sort of activity can be exposed to, and what we are calling transitional risks. And for this one, the definitions are typically varying. So I'll give you a few examples. Physical risks, it's about the fact that climate will change some of the parameters that are affecting us in the activity. I'll give a very straightforward example. For instance, lots of industries are using rivers to cool down their operations, and this cooling is only possible up to a certain temperature. And typically the cooling towers that we see, all the cold dams for power plants, as well as for transformation industries, such as agricultural industries, need a certain level of temperature in the river. With climate change, more and more, this temperature is drifting. And as soon as temperature has reached a certain threshold, all of a sudden you can't really operate the way you are doing to. In the past, we had heat waves. As climate is changing, the temperature in average in the world has already increased by 1.1 degree compared to the pre-industrial era. We had a certain frequency in the heat waves that we are seeing. We're used to see these rivers being at a temperature where operating the plant was not possible 1 year every 10 years. With what we've seen in 2022, what we are seeing in 2023, when it comes down to other resources such as water, for instance, the frequency of these events, as well as their intensity, is increasing. So when we talk about direct physical risk, we talk about more occurrences of storms, for instance, that will have an impact for anyone working outdoors. It will have an impact on major turnarounds in plants, because the seasons to do those might be really much more complex to manage in a climate that is changing. I've been working in areas such as Southeast US, for instance, in the Gulf Coast, when we know that some operations are not possible in summer. If we have more of these very hard summers, it means that anyone planning for a project, whether it's in buildings and constructions, in chemical plant buildings, will be affected by climate. And these are really direct physical risks. And in those, you also have all the events that are caused by more frequent hurricanes, low water, such as the low water level that we had on the Rhine River in the last year, for instance. This used to happen every 20 years, that chemicals could not be barged from Ludwigshafen to all the other plants in the area. Now it's likely to happen much more often in a different climate. This is a direct physical impact on the business. So, to add insult to injury, there's not only physical aspects of the risks, there are also all the other transitional aspects. Transitional aspects are all about the risks that are not directly physical. So you can think about reputation risks, for instance. In current environment, companies that are not doing enough to fight climate or to curb their emissions levels, for instance, will probably be much more exposed to societal criticism than they were in the past. That's a kind of intangible risk that is posed to them. Energy transition in itself is a risk. I will give you a very weird example that people never think about. I think everybody says that the energy transition, which is linked to climate, we want to reduce emissions because it's bad for climate. So we need to curb our usage of fossil fuels. If we curb this usage of fossil fuels, it means that there will be less feeds available for lots of other derivatives of oil, such as a lot of the plastics that we are currently using. And without plastic, we will probably not be able to build electric cars, we will not be able to electrify the buildings, we will not be able to insulate the buildings in a better way, so that we actually reduce our energy consumption. So it's a kind of a whack-a-mole thing where we are bumping on one mole, which is fossil fuels, but we are creating problems elsewhere. And all these transition risks for companies is about all these things that are not directly physical, but will be impacted, where their activity will be impacted thoroughly by climate change.
Thank you. It's very clear, and even if you take weird example, one of the remark I can have, it's really listening to you. It's really a systemic issue. It means you change something somewhere, it will impact in a certain way, and everything is linked together. So it's not a simple topic. So you mentioned a lot of hazards that companies will face. How can they assess these hazards they are facing and they will face tomorrow?
So what we've been doing, because of our industrial background, we used to do risk assessments that were called hazards of operations identification. And what you do in an hazard session is that you bring all technicians, all engineers that are operating a unit, you put them around the flow plan of the unit, and you just ask yourself, what can go wrong? And someone will say, if I close this valve, then it means that this vessel will be in overpressure, which will mean a leak, a rupture, or another trouble in the process. What an organization can do is something that we call HazClim, which is exactly the same thing, but applied to climate. We first map the activity. We map the value chain from cradle to grave. We really need to think about all the different aspects that there is in the business. And we are just trying to ask ourselves, what is this becoming in a world with energy transition, with resource scarcity, or with climate change? So I'll give you a very practical example. If you depend from transportation of natural rubber, if you are making tires in Europe, and you depend on natural rubber that is produced in Southeast Asia, there are lots of things that climate can change for you. First, it is not totally clear that rubber in 20 years will grow where it's growing today, because some of the regions might be too affected by floodings or heat waves, or not warm or cool enough at certain periods of the year, which means that probably the natural rubber will not be as prosperous as it used to be in certain regions. So you have a hazard there. Climate is a direct hazard. This rubber will be transported in harbors. Some of these harbors will suffer from more frequent hurricanes, from typhoons, because we are talking about Southeast Asia, that's how they call there, from lots of other inclements that will basically mean that it will be harder for you to transport these things over. And when it arrives, other things can go wrong. The quality might not be quite the same. We are seeing this. We have clients in the agricultural industry. They have seen that the crops, the wheat, is changing, which means that basically their cakes are not growing as much as they used to. And that's a big industrial problem. That's a kind of joke. When you are making your cake at home and you are baking it, and it's not growing as much as usual, you just have a word of excuse, But when you are selling a commercial product, these kind of changes can really tremendously affect your industry. So what you do is that you are really making the map end to end, thinking also about the way the customer behaviors will change eventually, because they might not choose the same products in 10 years, or they might not want the same packaging in 10 years than the one that they want today, all thinking about doing good for the climate, by the way. So all these things are really connected. And you are just trying to think what can go wrong at each step of the process.
Okay, so what you describe is really this hazard analysis that industrial are used to do. But how do you translate this into risk in order to start to understand and identify the proper action to take?
Well, what I realized is that many of the organizations that we work with have a tremendous experience in risk management. What we see too is that they have a lot of knowledge about their business. What I see also is that sometimes they are more reluctant to learn a new thing. And so what I think companies and organizations should be wary about is like try to see what you are doing, which is quite similar to managing climate risks, and try to extend basically the scope of what you're doing. So it really depends. In some cases, we come with like tools, that we have, and we have matrices and tools that help you capture the hazards and then give them a quantification. And the quantification is always the same. It's like probability of occurring and impact of the issue. A big hurricane every 20 years is a problem because it might mean that you need to totally rebuild the plant. So you will multiply the extent of damage that you can think about with the probability, and that will give you an indicator of like how bad that is. What we see, and then we've been working this with different sorts of clients, some don't have anything at all really to manage this kind of risks. Some others are very good premises of doing that. They have business continuity plans or strategic procurement plans, for instance, that are encompassing this kind of dimensions. And what we are doing is like, hey, you should think climate too. I mean, you think before like you needed to have 2 or 3 suppliers just because one might go bankrupt and you might be left with no supply. I've lived this as an industrial in charge of procuring certain critical raw material. And it's not because something only accounts for 0.5% in your recipe that it might not be a problem. So you have to be very, very careful and digital with that. Because without the salt, you can't bake your cake. And the salt is only 0.5%. So if you are really depending on a certain resource, and I mean, just as much as I do that catalysts and other additives can be absolutely critical and very often overlooked compared to the base raw materials, you need really to go into these details and give them a risk, an assessment, an extent, and an impact, and put them in a matrix. If you have your own matrix, that's great. I've seen like, 3x3, 2x2. Some are just giving an index or kind of risk score. But the key to it is like understand for each of the hazards, how will it impact? What is the extent of damage that something can cause to you? And how essential is it to your activity? And how often will it happen? And probably the other thing that people need to think about when they are trying to turn this into quantifiable risks, don't think about the past 50 years. As a young engineer, when I was designing a cooling tower, I would have a look at the weather. I was along the Seine River, so basically the Seine River climate hasn't really changed as much in the previous 50 years when I started working than it has changed in the last 20. And so if you continue to build projects or assess your risks considering historical perspective, you probably have to think different and try to get the data about what will the situation look like when the world is 2, 3, 4, or 5 degrees higher.
Yeah, and this is really, I think, one of the main difficulty, because you mentioned the word probability, and I think one of the difficulties for people and industrial, more precisely, about climate change is we still have a lot of uncertainty about what will be the scenario that will happen. And you say, okay, 2, 3 degrees, 1 degree more change a lot when you design installation. So is there approach today to incorporate this uncertainty in the risk analysis, because it can change a lot, and a bad I would say forecast, because it's just when we talk about forecasting climate, we know it's a very difficult exercise. Huh? So there is some, I would say, a balance between anticipating certain scenarios and the cost of investment related to put the proper measure and decision related to these scenarios.
To me, it brings a solution that really can be summarized by 2 words: scenario planning. So just as a personal note, I'm a type A engineer. I'm sure that there is an answer and I will find it. And that's probably as long as I was working in a world that was requiring some certainty and had long-term trends that had never changed. And I think I started really to change the way I approach things fairly recently, thinking more in terms of, you know what? I've tried to forecast how much I will sell next year, what the cost of oil will be next year, what the price of selling my materials will be next year, and give a very precise number. And what I realized is that I've been pretty consistently wrong. And what I've learned from that is like, you know what? Rather than to think that I can really find a solution, why not do I try to find what are the different zones and the different scenarios where I can actually, drive results that regardless of the conditions, and try to establish more ranges. And I think that, and that's probably a misconception about the IPCC reports, le GIEC in French. They are not talking about a number. They don't know exactly how warmer the climate will be. What they are saying is that there is a likelihood that this will be between this range and this range. And I think the idea is like you should use these ranges and articulate responses and try to find the low-hanging fruits where you win no matter what. I will give you a very simple example. There will be more storms. Storms mean storm surges when you are in areas such as polder areas or harbor areas. Basically, there is less, when there is a big storm like some of the ones that we've known in France, like Xynthia, for instance, the low pressure is kind of sucking out the sea, and the sea levels are rising dramatically. You can make lots of calculations. You don't know exactly if the sea level rise will be 1.1 meter or 1.16. As a good engineer from the École des Mines, I can calculate you very, very precisely how much that would be. I'd rather today use actually another part of what I learned, which is like statistics and probability, to say, well, there's actually a 80% range that it will be between 1 meter and 1 meter and 50 centimeters. There is a 20% chance that it will never reach 1 meter, and there is another 30% chance that it will be actually above 1.5. And what we are doing with companies, like when they have a serious team of projects, some of them can protect them in the base case and bring a business which is more resilient in 50 or 60% of the scenarios. That's what they should do first. So on top of like having this probabilistic approach to the events that can occur, you should also integrate the scenario planning and the probabilities into the actions that you want to draw, and to be basically statistically better off. But there are a couple of things that we already know that can really give an influence. When people think a climate at +2 degrees, it's quite likely. I can't tell you whether it will be exactly 1.6 or 2.5 or 2.6, but at some point in the next 50 years, we will all collectively have to face something which is likely to be 2 degrees. Well, if it's 2 degrees, then the events that used to happen every 10 years will happen 3.8 times more, basically every 2 to 3 years. So the heat waves, like the one that we've known in 2022, they used to be, I'm old enough to remember a few. Our kids will probably see like the same kind of events 3 times per decade. Then basically you start to think in terms of like probability are increasing. So I should also think in terms of probability when I'm deriving my actions.
I think you really, it's really interesting what you said, because it's really not a matter about being too pessimistic or about climate change, but really to think about how we can gain resilience, how we can adapt, and industry can adapt to be safer in a world that is changing in a way. Having said that, this way you identify the climate risk impacting your industrial activity. How can the company identify the proper action and choose and prioritize their actions based on this risk analysis?
I think, as usual, as industrial, whenever I was asked to make the decision, I would ask, what does it bring and how much does it cost? And here we're no different. We're just doing the same thing. So we are doing I recommend that people do this climate risk abatement curve, which means like you really rank the seriatim of how much does it cost you to actually be more prepared to a certain risk compared to how much credit this can bring to your company. So I'll give a pretty straightforward example. You can find the cost of doubling the capacity of cooling, for instance, to be able to better withstand heat waves. Power plants had an issue last summer. All of a sudden, everybody realized that actually solar plants and nuclear power plants and thermal plants actually don't perform as well when it's really warm than they do when it's really cold. So it really means that we've all been learning the principles of thermodynamics the hard way.
It's like for internal combustion engine that we are using every day in our car. So the hotter it is, the lower the yield of the engine is.
It's effectively pretty good heaters when you think about it. So thinking about this kind of risk, if you want to cover for them, you will need to increase a little bit the efficiency of the cooling systems, or to invest into a new cooling water, or to think about a totally different way to rethink your cooling. And depending on the level of investment, they will have different impacts on reducing the risks. You might be covered for better for the mild heat waves, but maybe not as much for the very extensive and high intensity heat waves that we might see in 10 or 20 years. But you might want to prioritize your actions and have this seriatim of understanding, which kind of level should I invest in first, and really focus on the ones that are actually bringing benefits with the shortest payback time. They are typically the easiest. Think about also, and companies should also think about the adjacencies and the fact that they will not only benefit on climate, but might be a better use of energy. Reducing energy cost is paramount. When you can, at the same time, be more prepared for a climate that is changing and reduce your energy consumptions, you really want to do that. That's why anyone who has a house today is being told, first thing that you need to think about before you are thinking about a heat pump, before you are thinking about a new digital way to pilot your whole installation, think about insulating the roof, because that's where every calories are going away. And companies can really build exactly like we can for our own home, build the seriatim of actions that they can do, and put in perspective the time it takes to actually do them. I mean, we've been in industries together. We know the time it takes to design a new boiler. We are talking 5 to 10 years to change the boiler. So you have to think long term. But in the interim, what can you do to actually, save the energy or be more protected for climate? It's the same kind of arguments that stand here. So build this curve that will, and let the curve do the talking. That's very easy to, actually, when you have good data and good systems to put this data in perspective, it's very easy to make the decisions. The curve is really doing the decision for you.
And in fact, we come back to what you said previously, is the approach, the methodology is very similar to what people in industry are used to do. It's really standard. It's just that the input data is a bit new because you take a new parameter into account, which is the hazards linked to climate change.
So you're bringing a very good point that makes me think about something else, which is competencies. Today we are dealing with companies who are starting their journey with climate change or with greenhouse gas emissions reductions, for instance, and I realized that even the most competent managers and engineers typically lack the right orders of magnitude, and I would say the basic toolkit to navigate this new reality. So it's great to think that you can just add climate to whatever systems you had, but I think the first thing that you have to do is really think, in my organizations, do I have the right competencies to manage this? Again, I'm old enough to remember when we implemented quality in the plants, or when we started to work on implementing safety management systems, the first thing that we had to do is to explain to people what is an accident. How can you say that you want to become safer if you don't explain to people why there are accidents, how do you count them, why do you report them, what are the different categories, and what are the different options to do that? And I had countless trainings around this, about behavior-based safety, about managing and reporting incidents in the workplace, about continuous improvement loops. We just have to think the same with climate here. And I would say that maybe the first thing that people have to do is just to think, how can I know what I need to know? And how can I learn what I absolutely need to have in my basic toolkit?
So we talked about methodology, so this is not new for industrial companies. You mentioned clearly the aspect of competencies that is very specific to this new topic. But do you think technology and data have a role to play in climate risk, in managing climate risk?
Well, absolutely. I think if you get to the point where you realize there's an issue and you build your competencies, as you said, the next thing that you want to know is like, how do I measure all this? And then you realize that there's a whole set of data that are sometimes present in the organization, but not used to monitor like a climate change or weather inclement, or data that you actually need to make better decisions. So we are working, for instance, with companies that can provide us very precise data set about what will your place look like in 20 or 30 years with a different climate. What kind of heat waves will you see? What are the average temperatures at night? What are the moisture level that you will see? It's very important for the industries that are depending a lot on soil management, for instance, or temperature to run the processes. They need to have this basic data that maybe they don't have. And for the rest, what I realized is that lots of companies are measuring data, but are probably not using them for that purpose. What I'm seeing by that is like, I've been running in-house plants to know that you are monitoring basically your compliance KPIs, your key performance indicators that are the ones that are in your operating permit you will monitor. So remember, monitoring very precisely is the temperature of the water that we would send back to the river after our plants. We would track this because there was a mandate that it shouldn't be higher than a certain level of temperature. We are not making great use of actually the upstream data of the temperature of the river upstream that will have an influence on the temperature of the water that we will just send back to the river. So companies really have to think, once they have defined all these scenarios and one can impact them, they have to identify what are the very important leading indicators that will make me think that they will have a problem. And some of that might be supply chain. Someone who is really heavily dependent on the harbor of Hong Kong probably have to have somewhere in the organization someone who is extrapolating weather data to know whether the typhoon seasons will be higher than normal or not. And so there's a lot of the new data that organizations need to acquire to understand and pilot better their activities. And maybe incorporate this in like supply chain risks. We know that every year the NOAA, so the weather forecasters in North America, are issuing a ranking of what they think the hurricane season will look like. Because if the Gulf temperature is very warm, there's a lot of potential energy to have a big hurricane. And I lived in Houston through Harvey, and I know what a big hurricane looks like, especially one that is bringing you meters and meters of water for a couple of days that will basically totally destroy some of the infrastructure and grind the whole supply chain to a halt. You have ways to anticipate all this. And this lies into the data that you are either collecting today but not making very good use of. Everyone kind of takes the water temperature intake. It's somewhere. There is a tag somewhere in the system, but you are probably not making good use of it in a predictive way related to the scenarios that you might have identified that cause you problem in the climate change.
Can I summarize what you said? I think in 2 points in terms of data. That first you need also data at the macro level to anticipate and to have a global view of the supply chain worldwide, etc., that can impact you. And also you need to put in place your own data collection locally to have an understanding on how your local environment is changing, and in order to adapt what you did with the scenarios to see which scenario is becoming real or not, so to adapt also your answer to this climate risk.
There is a big cloud of input that you need to structure in a way that it's giving you the predictive tools that will let you know whether you run into a problem or not.
We talked a lot about physical risk and physical risk management for industrials, but you also mentioned the transitional risk. So, based on this physical risk management, how can company leverage it to also impact their transitional risk?
Yeah, that's a great question. I think it highlights the fact that when you work in an industry, you are really thinking physical risks, and that's what we see. Most companies today want to see whether they can run their plants. It's what I call end of the month before end of the world. And transitional risks are a lot about end of the world or end of the world that you live in. So I think the two have really to go in parallel. They can't be like sequential. You really have to think in parallel. The transition risk can be subject to lots of things. Transition in your value chain, upstream and downstream, change in what your consumers want, on what the customers want, on what the regulators want you to do. And upstream, will any of the changes and any of the transitions that you talked about will impact your value chain? Will you have less product because all of a sudden we are transitioning from an oil-driven world to an electricity-driven world? This might have a tremendous impact on your value chain. I think that doing the two in parallel is actually a very good exercise for the companies, because it makes them think and challenge their view of the future. This famous end of the month versus end of the world thing. And I think it really brings all of the managers, especially the senior managers, back to a responsibility, back to an accountability which is different. It's all the matter of like, your shareholders expect you to deliver results by the end of the year, but they also expect you to defend their investments in the long term. And I think everything that you are learning in managing risks, whether they are physical or transitional, are building a company which is more resilient. It's a better investment for the future. So all of this really accounts for building a better future for your company and a better prospect, and in the end, a better investment for your investors.
Anyway, I think what you mentioned is really in line with what industry were used to be or should be. That means always with a long-term approach. We talk about very large investments. We talk about a very long period of time to build your facilities, etc. So industry has to think long-term. So what we discuss during this exchange is really what is the long-term impact of the climate change on the industrial business. But today, if one industrial has or wants to go in this approach of risk management, climate risk management, what will be your recommendation, or how can it start moving toward this kind of approach?
I think most of the clients that we work with, what we are trying to do is not to build a separate department that will take care of climate. I don't think it's really working well. I've been in that before. It's like, you don't really want to have a digital manager that never heard about digital, that is taking care of a whole division in the company that will not be integrated with the rest of the company. What I think you have to do is to think, what are all the processes that you have that have a level of risk and dependency on certain elements that can be affected by climate at large. So assuming that you have actually a C-suite that have been through a training and that has raised competencies and awareness about how climate change can theoretically impact you, they really have to think back into all of their divisions: supply chain, production, procurement, research and development. How do you integrate climate into all these different elements that you have? If you have a quality system today, it's quite likely they ask you to do a risk assessment. Integrate climate into this. When you ask your engineers to bring opportunities forward, you ask them, if you want to build a new plant or identify a new asset, you probably want them to tell you whether they are safe to be operated, whether they are dependable, whether reliability will be up to the rest of the standard of the rest of the plant, whether it will drive financial results, whether it will be safe to be operated. I think that you might want to add, will it actually still be operable and profitable in a world that has changed 20 years from now with a climate which is all different? And integrate climate into these business reviews. Every time that you can put a little bit, another layer, it's much, much better and much easier for the organization to embrace the transformation where you just add one other parameter than when you start from scratch. So I would really encourage them to start to be really tactical, understand the strategies that are behind, but then being very, very deliberate in saying, hey, we need to put all these little seeds everywhere in the organization so that they see. The other thing that I would encourage them to do is also to have a look on what is up to them in terms of mandate. Mandatory requirements are increasing for companies to report climate risks and climate exposure. It's a whole part of the CSRD, so the Corporate Sustainability Reporting Directive put forward by the European Union, which says businesses have to analyze and understand how they are exposed to the changes coming up with climate. So think already about the things that you have to do. Whether you are sure or not that climate is changing to 2 degrees, 3 degrees, or 4 degrees is very different than thinking that you have to comply with the reporting requirement in the next 2 to 5 years. The financial community is already gearing up for that. The TFCD is there, and what they are doing is just that. They ask companies to say, we don't want stranded assets. You talk about investments, long-term investments. The last thing that you want is that you build a plant which will be not operable or have no market in 5 to 10 years. And climate can really change a lot what will happen in the next 5, 10, or 20 years, which is 20 years in an industrial environment is basically the great age. It's basically a very reasonable time frame in the industry, which has typically been very, very long term because of the amount of capital that you put in the ground.
Thanks, Maxime, for this very, very clear description of what is the climate risk management. I think it will ring a bell to many industrial, because it's really, I would say, in line with the way of thinking of industrial with risk assessment, etc. So thank you very much, and hope to talk with you soon.
Thanks for having me.